And I'm already sharing my screen, right? So we're set to go. All right. So yeah, let's get started. Okay, so for the assignment, so almost everybody turned in the UML, and your feedback is on Moodle. But for those of you, I also provided here a full correct example of the UML, which will also be helpful for you for the assignment. And I just want to walk you through sort of how to create the UML from a specification, right? So going actually through your UMLs was pretty helpful, because I got to see, just your thought processes and how things, how you put things together. And one of the things I noticed is kind of connecting rational sets and kind of to this particular example, right, to this particular assignment. And so I just want to kind of walk through how you would go from a spec to a UML and not sort of conflate ideas from different assignments, okay? So I'm trying to think, what was the example I saw? So there's a couple of examples. They included sets, but there's nothing in this assignment about using any kind of sets, right? And then the other thing was the names, I think, of some of the functions. I want to say it was like an add function, and some people added different functions that were not really required. Okay. And so just so you know, as I was kind of going through this, what was I looking for, right? So, okay. So first of all, when you talk about UML, with the UML, we're talking about class diagrams, right? So whenever we do a UML, this thing over here, right? This is called the class diagram. So what that means is it is showing us how classes connect together, right? So what does one class connect to another class, and so on. And I know in like the 250, we haven't done a lot of classes, right? The most we've done has been 2, right? And I gave you a hint last time how in sort of bigger programs, and as you do more CS, you're going to create these bigger and kind of more complex class diagrams. But what we don't ever show inside of a class diagram is the driver or the main or any non-class stuff. So I'll make a little note here so you have that too. So no driver / main in a UML class diagram. Okay. The other thing I want to just tell you about UML is UML is used, it stands for, I know you've forgotten, it stands for Unified Modeling Language. It's used actually to model, it's used for lots of different diagrams. So one of the other diagrams we might use for it is a sequence diagram that kind of shows you how you would proceed through a program. You don't have to worry about any of that. The only thing you need to care about is that the only UML we're doing is class diagrams representing classes, okay? And again, as a reminder, they're used to communicate, right, with other people. And as software developers, you go through sort of several stages before you get to the software, right? And so generally, when you're designing software, you're designing it for a client. So you're going to meet with a client. The client is going to speak to you in some language that kind of looks like this. This is actually even more specific, but they're going to come in and they're going to come up with a bunch of requirements. We want it to do this, we want it to do that, and so on, right? And then somebody else is going to come in and be a little bit more specific and create this UML diagram so that you can communicate with the developers who are going to actually do the coding, right? So there's kind of these several stages, and where we're going from our human language of what we want, which can be very fuzzy and messy and ambiguous, right, to something that we can really code up. So for Tia, for this class, what you do right now is you're given a spec, and what I asked for you to do is to design a UML that followed that spec. And by spec, I mean specification, software specification. Okay. So going through here, you need to have a class named course, right? And it's going to represent the information for one course. So now you've got this down, right? That when we create a class, it's a blueprint, and I can create as many objects of that class that I want, right? So here, if I have a class named course, I can create a CS250 course, or I can create a CS300 course, a CS150 course, right? And those are all the different objects. So we know that we're going to have one course. And then we've got to think about what is the data that we're going to have inside of that course, right? And so the top part here we know is the class name. The second component here is the data that we have that we're going to be storing inside of the class. Most of the times that data is going to be private. And so what I was looking for is, we know we're reading in from a file, and we're going to be reading in like a prefix, an integer, a prefix and integer, and then two other integers, right? And so I just translated those and just straight away said, okay, that if I'm reading from a file something that says, CS 250, capacity 48, I don't know, some number 37, then I'm just going to store those in there. So I will need something to store that prefix. So CS, I would need something to store that number. Now, some of you represented that as a string, and that would be fine. I mean, so it's an interesting concept, but it actually would work because we never use that as an integer. We don't add on to that number, right? It really is just it represents a string. It really just represents something fixed. It doesn't represent a number necessarily. Then we have a capacity, and then we have an enrollment, okay? So those are the data items that I would expect to see here. I think some people had maybe a some static constants in there to say that we only allowed CS and we only allowed math. That's great. If you have those static constants in there, brilliant. But you don't need to. I wasn't going to require it. Okay. So that's the first part, is figuring out the data. Then after that, my spec kind of nicely breaks down the main functions that I'm looking for, right? So the first thing I ask for here is an appropriate constructor. It's enough to just have a default constructor that takes no values, okay? The second thing I ask is determine if a course is full, if it has space for a student. So then this is where you kind of start looking at the UML and writing it out. So I named my function is full. It's okay, whatever you named your function. But basically this function is going to look at a course. And remember, because this function is part of a course, all of these functions have access to that data. So inside of this is full, I can already check if enrollment equals capacity, right? And if enrollment equals capacity, I'm going to return true, right? Otherwise, I'm going to return false. So, so I guess what I was looking for here is that you have a function that represents the description up here, and that you notice the parameters. In this case, we are not going to be passing in any value. And then the return type is going to be a Boolean because it returns a true or false. Now the const, whether you had it or not, I didn't actually take any points off, but it makes complete sense. This would really have to be a const because the function is full, is not going to be modifying the data. Okay. So that's that one. Okay. And then we go to, I'll pick a different color for the next one. So the next one says, determine if a course matches a passed in prefix and course number. And if you look carefully at the description, I'm telling you in here, right, that I'm passing in a prefix and a course number. I'm not passing in a course. I'm not passing in nothing, right? I'm passing in two things, which are the string and the integer. So if you look at my description, I'll make it a little bit bigger. But if you look over here, I named it as a match, whatever, you can name it, whatever you named your function, right? It takes in these two parameters representing the prefix and the number, the course number, and then I return true or false, the Boolean, okay? Because if it matches, it's going to return true, and if it doesn't match, it's going to return false. The other thing is I made it a const function because we are not changing, we're not allowed, this function is not allowed to modify any of that data. Okay, so that's how we match. That is match. All right, so then let's look at another one. Let's look at, I'm just going to pick different random colors here from my picker. Okay, the next one says we've got an overloaded C++ operator. So there we go. There's my operator plus plus, right? An overload plus plus operator. So there's my operator plus plus. And this one is actually even more straightforward than the other ones because I've shown you what it is, right? So there it is. The first thing is the name, and the name is operator plus plus. This plus over here represents that it's public, right? And we need it to be public because the object's going to use these. And then over here, the return type is course by reference, and that's what we have over here. Right? Because in UML, you put the name of the function, pass in the parameters, and then colon the return type. Okay. And then the last two that we have are the operator extraction, which is the read in operator. I think for this one, what I noticed there were just issues mainly with like mixing up the I stream and the O stream and so on, right? So remember that I stream is one that you'd show with a C in. So these ones are friend functions. So remember, whenever we use operator plus operator insertion and operator extraction, those are friend functions, which means that they're not inside of course. They don't have an object. They're not inside of an object of type course. So these ones need to be passed in their object, right? And they also need to be passed in whatever stream they're going to be using. And they also need to return a stream so that we can chain couts together or insertion streams together and extraction streams, right? So that's why they need to return the I stream and the O stream. And the one thing to remember about these two, the operator ones, is they're actually very, they're the same. Whatever class you have, if you're implementing an operator insertion or an operator extraction, or an input or output operator, then they're always going to be the same, no matter what class you have them in. The only difference is what object you're passing in. So here, this has to match whatever class we're in. Other than that, they're always going to have an I stream by reference, an O stream by reference, return an I stream by reference, and so on and so forth. Okay. And so that's what the UML should look like. So that really says, okay, you now have this UML, I'm giving it to you. You can go ahead and just implement that as a class. And going, as you can see, right, as you go from, we've gone sort of, somebody else maybe gave me the requirements. I wrote it as a spec. You took the spec, created a UML, and then now going from the UML to the C++ is even easier, right? We're the next step along. Now it's just, I just got to type in the words that C++ understands. And then I have to fill in the functions, right? Fill in how these things work. Okay. So that is your course class. Any questions? I'll bring up the chat here so I can see it. There we
go. I have a question. Mm-hmm. When I do like an array, like once I go into the into main or something, and I'm not related to UML, but I'm just wondering like the order of, like I had like an array and I had PAC and then I said course or something. What if because it's like a pointer to an array of class course, but then what if I had it like what is it, like opposite, like AP and then like
are you just worrying about, you're just worrying about the names, the order of the A and the P and the C?
Yeah.
Let me, you know what, I'm not going to answer that off the top of my head. I'm going to bring up our coding standards and see exactly what it says on the coding standards, because I don't have those memorized.
No, it's okay.
Yeah, no. It's nobody should have those memorized. They're there for a reference, right? So I'm just gonna organize my windows. All right, I'm in the wrong class on Moodle, so I'm gonna bring it up and just see what it says about the coding standards. So that's also always helpful. I'm actually going to stop sharing and I will share the coding standards as I bring them up. So CS 250 2021 01, is that right? I've got all my CS 250s. And then I'm going to open up the coding standards and I will share that screen. Actually, I'm going to have a quick look and see if it even mentions it. Yeah, I don't think it does mention it. Actually, I'm going to show it to you and then see what you say. Okay, let's see. So I'm going to share screen. Now, unfortunately, this is on my laptop, so I cannot, there we go, cannot write on it necessarily, but okay, so you see the screen right now? So this is the coding standards directly from Moodle. This is your coding standards. And the question that Ashley is asking is about the names of the variables, right? So if you go under variable names, we kind of talk about what those variable name prefixes should look like. And we have these examples, right? A reference should start with an R, a pointer should start with a P. We have simple examples, an array should start with an A, a class object should start with a C. And then we're given a little bit more complicated examples. Okay, and so an array of structs is kind of like an array of class objects. So you always start with A. So it's going to be AS for array of struct, or AC. Actually, there it is, array of class objects. It's an array of C. And then if it's a pointer to a class object, it's going to be a PC, right? Pointed to a class object. So the question Ashley has is, what if we have an array of pointers to class objects, right? And so then it would be APC. I think it would be the correct way to do it. So it's an array of pointers to class objects and then the name.
Okay, thank you.
Yeah, so APC, okay? Though technically, if we're, as we're grading for coding standards, we wouldn't take points off if it's PCA or anything like that, because it's not exactly specified, but it's usually the way you say it. So it's an array of pointers to class objects. Okay, any other questions? That did not share? Oh, there it is, okay. Okay, so what we're going to do, if everything's good with the assignment, right, I will probably, if you have time at the end, which I think we should technically, but I will going to kind of walk through creating an array of pointers to rational and kind of play with that a little bit, okay, which will hopefully help you with this assignment too. All right, so going back to pointers, so your pointers class, we're pointers lecture notes, okay. Okay, what did we get to? Yeah, so I'm gonna move back to where we haven't covered. So we did all this new and delete stuff last time, but I'm gonna finish talking about pointers, which we didn't talk about pointers and functions, I think. Yep, pointers and functions is where we haven't talked about. And then I will go back and we'll try and work through a problem today that will be hopefully be similar and helpful for you as you work on the assignment, okay? All right, let's look at pointers and functions. So what are the two ways of passing function or passing arguments into functions? We've been using those, you've been using those for a while, is we know that we can pass by value, right? These are like burned into your memory, your brains now, right? So we can pass by value, we can pass by reference. And we know that when we pass by value, we make a copy. When we pass by reference, sorry, we are referencing the original object. Okay, or original, whatever it is, original argument, I guess, because it could be a variable or an object. And then with a pass by value, we don't do any, there's no symbol or anything, but in the pass by reference, we know that we use the ampersand, okay? And I'm not going to write the square one and maybe it's, I don't know, maybe it's worth doing. Okay, let's write a square one and a square two. One is going to, so it's going to square two values and return the square of those numbers. So if I do, are they integers? I think they're integers. Okay. Square of an integer. Yep. So if I do int square one and I pass in an int x, right? Then I know that I can, if I pass in the x by value, then I know that I can square that number and call return x times x, okay? And that would return the square of it, right? And I know that in main, if I wanted to use this function, I could do something like int main and then do, I could actually just int s, I'm not in the mood. So s is the square one, and I can pass in any kind of numbers such as, or any value such as a literal, like a integer literal, like 3, and that will square the 3 and return it, okay? But if I wanted to do it as a reference, then I could do int square, actually, I'm gonna do that void. So it's gonna be a void square 2, and I can pass in int by reference x, right? If I wanted to store it in the same value, I'm trying to decide if I want to do it in the same location or not. Maybe just do a different one. So we can do the int x, which is just our value, and then I can do an int by reference and call it our square, right? And then what I can say in this case, sorry, it's open parentheses, is I would do s is x times x, right? So again, I'm squaring x and storing it in some other value in both of these cases, except now the way I can calculate the sum is, or the way I would call square 2 is to say square 2, and I pass in my value, my 3 for my x and my s, right? And both of these are going to do the same thing in that they're both going to get the square of the 3, and they're going to store the answer in the s, except one is doing it in a pass by value and one is doing it as pass by reference, okay? That is just general review of pass by value, pass by reference. So questions on that? Okay, I'm going to do something. I don't know if I'm going to kind of jump ahead and just talk about a third way of doing it, which is pass by pointer. All right. So with pass by pointer, what I'm going to do is, in some ways, it's similar to pass by reference, but instead of passing a reference to the variable, I'm passing a pointer, so an address of a variable. So let's look at void square 3. And so square 3, again, it's going to do the same thing in that I'm going to take that x, but the other variable is going to be a pointer to the sum, right? Or the square, sorry, the place that's going to hold the answer. Okay. And then I'm going to say that inside of s, I'm going to store x times x, right? So I have to dereference because s is a pointer. Well, actually, let me make it clear that it's a pointer. We always name our pointers p. So ps is a pointer, and then ps there. Okay, so I just changed the name. So let's have a look at what we're doing. So here, I'm passing in an address, right? So ps is a pointer to an integer. That's going to hold the result of our calculation. X is just the value that we're going to be doing something with. And here I'm squaring x. It's going to do 3 times 3 or x times x. And the answer I'm going to store is going to be stored in whatever ps is pointing to. So I dereference the pointer and I say that's what's going to store s in that location. Or so it's going to go store the x times x in that location. Okay. So any questions here? Okay, so now what I want you to do in the private chat, so we can all see where we all are. Tell me how would you call square 3? How do you spell square? I've done it all wrong, guys. All right, square 3. How would you call square 3? That's it. Write the code that we'd use to call square 3. There we go. So do that in the private chat and send it to me.
Is square 3 a function or a part of a class?
There it is, just a function right there. There's no classes, it's right there. So Ashley, remember the name of the function is square 3. It's got to be somewhere in there. So here I called square 1 with a pass by value. Here I called square 2 with a pass by reference. Now I want to call square 3. Okay, so Taylor, that's good, but you haven't defined what the PS is. And if you look inside of main, all I have inside of main is S, and I've been using a literal 3. So they're the only variables. If you want to use any other variables, you need to tell me what those are, okay? Let's see, Ali, not quite. I have a question mark on there. So it's not quite that, because if we just used S, right, that would be the same as before. That's an integer. S is an integer. Here I'm passing in a pointer, right? Let's see. Good, Jordan. I think that works. It kind of works. You're going to get an error, but it's a subtle error that I'm not sure that you'd quite see. The error you're getting, Jordan, is because you've declared PS to point to an integer, but you haven't made it point to anything. And then you're storing something in it, but it doesn't have an address. You see what I'm saying? Yeah. All right, Daisy. So again, Daisy, you're using PS, but in main, there's no PS. Okay. Okay, so Casper, it's not quite. So again, thinking about our uses of stars and what does that mean? So star would always, in this case here, it dereferences a pointer, it follows an arrow, but S is just an integer. And so putting a star in front of it doesn't do anything. See what I'm saying? Sarah, nice job. Very good. There you go, Taylor. You got it. Yep. Okay, Ashley, I was scrapping something up there, right? Okay, so Ashley, same thing that Jordan, you've got this PS, but PS is an integer, and then you're passing it into a pointer. So yeah, to think about that a little bit. Caden, nice job. Okay, not quite, Daisy. I think I see what you're trying to do. It's just the syntax is wrong. Okay, so bear with me and we'll look at it. But I see what you're trying to do with that. Ali, you got it. Yeah, there you go. Okay, Elijah, again, this good. This is you're very good in declaring that PS and passing it in. The only issue is that PS it doesn't have an address in it. It's like it holds an empty address, and then we're going to try and put something in it, and so the compiler is just going to freak out. He's not going to know what to do with that. Okay, so again, Casper, good, getting there. But what type? Did you already do? Maybe you did it above. I was just going to see what type you had PS. Yeah, so you haven't done that. So what type is PS? So notice here I have no PS. So you're using it, but I don't know what it is. No, not quite, Ashley. Trent. Not quite. So there's a few issues, Trent, with yours. You got 3 arguments, but we only accept 2. So that's sort of one thing that I'm noticing. And then in a function call, we never use a type. We always use just the actual variable names and stuff. And so you have a type in there, so that doesn't quite work. Casper, it's not a type int. So make sure if you don't understand pointers, this is our 4th day on it, make sure you go back through the notes and try and get it, okay? Because yeah, it's important because we can just keep moving forward. But the more we do it, I think the better practice you'll get. Okay. It's fine. But even without the 5, Trent, it's still not quite, because again, here in the function calls, we don't put in any data types. Okay, so just need more practice. Have you gone through the Zybooks? If you go through the exercises on Zybooks, they walk you through pointers very nicely. There's a whole chapter on Zybooks, which I think I have actually at the beginning of this. I can't remember if I put it on there. Yeah, maybe I didn't. But anyway, there's, oh yeah, I did. So it says chapter, here I go, chapter 8 on Zybooks. So if you go through chapter 8 on Zybooks, it has a nice walkthrough of it. All right, where was I just now? There we go. All right, good job though. Yeah, and by the way, everybody, the pointers are confusing. This is not, it's not like pointers are like the easiest thing in C++. That's why pointers are, I mean, they're so important that they're used everywhere, but then, but they're also confusing conceptually. So that's why they ask them a lot on interview questions, right? Pointers come up a lot, like programming competitions, interview questions always use a lot of pointers. Yep. Okay, good. So yeah, all these 3 functions are doing exactly the same thing, Taylor. Okay, we're just doing them in a different way because again, what I'm illustrating here is just, again, giving you more tools, right? So you don't pass by value, pass by reference. Here's another tool, another way of passing into functions, okay? And in this simple example, they're all doing the same thing. But let's go back to doing, going through the code here. All right, so the first two, we don't use any memory addresses. The third one, we are going to use memory address. It's a void function, so similar to the reference one. We're just going to call the function, so it's going to be called square3, and we are passing in 2 parameters. The first one is an integer. I'll stick and do the same thing as the other one, so we can pass in, say, 3. And then the big question is oops, that's a comma, is what are we going to pass in to here, right? So what the function is expecting is it's expecting a pointer to an integer, right? So when I say it's expecting a pointer to an integer, it means it's expecting an address of an integer. So looking at, I'm going to go to this function and kind of just draw what its memory might look like, right? So when we come into the function, I have an x, right? And we know that this is a straightforward pass by value. So the 3 is going to get copied into x. So I'm going to put the 3 there, right? And this is, sorry, memory. Okay. And then I have this PS, okay? And PS, what we want it to contain is an address, right? Because it can a pointer to an int means it contains an address of an integer. So it needs to contain an address of an integer. So let's say that x, the address of this is 1000. Then what we want at the end is for PS. Actually, that's not the right one. We want at the end is for PS to be pointing to or contain the address of some value somewhere. I'll put it down here. Maybe this is 1000, right? And that location is going to hold the solution, right? So what we want is we want PS to be containing the address of some location down here, so that once I've finished and I finished my function here and I've done x times x or 3 times 3, it stores the 9 in that answer. So when I say star PS, it's basically saying follow the arrow, right? So x times x does the multiplication. The answer is stored in whatever PS is pointing to. So PS is pointing to this location here. So the answer is going to be stored inside of that location. Okay. So then the question is where is this location? What am I going to pass into PS? So what I'm passing into PS is going to be an address of some location to store the answer. So if I'm looking in main, right, here I am in main, I want to store the answer. If you look at it in all the other ones, I've stored the answer in S. So I've stored the answer in S over here. I've stored the answer in S over here. So I do want to store the answer in S. So we kind of draw the picture now, and we're like, this is kind of in main, right? But we're going to store the answer in S, right? And so if I want to store the answer in S, what I need to pass into PS is the memory address of that location S. And I can do that in 2 different ways. I can just pass in the address of S, and that says the address of the memory location S, and puts it inside of there. The second way of doing it, another way would be, let's do it. I'm gonna get my green pen here. What I could do is I can create an int star PS if I wanted to, okay? And all that this star PS, remember we have 2 sections of memory, sort of one belonging to main, one belonging to the main function, one belonging to square3 function. So here I have an S. I can also have this PS, right? And if I just did PS and then I wrote my function to be this should be small s, square3, and I pass in 3 and PS, then it's not going to give an error because PS is a pointer to an int and its PS here is a pointer to an integer. But if we look, this PS, we never actually assigned it anything. PS is just hanging about there, it doesn't have a value. So if I just ran the program as is right now, it would actually crash at this point. It would crash when it got this PS, And it basically what it does is it takes a copy of whatever's in here and puts it inside of here. And then it tries to dereference that pointer. So if it's dereferencing a pointer that never contained an address, it's going to cause a exception, a memory exception, right? Which is going to come up and just crash your program. And so the other way to do this, to fix it, is to say that our PS is going to contain the address, in our case, of S. So once we do that statement, then what that means is PS is now pointing to, so this is a PS in main, is pointing to that location, or it contains the address 1000, right? So then when I call my function, it's going to copy whatever is in this PS, which is 1000, into this PS over here, which is 1000. Just like it copied that 3 into X, it's going to copy that address into that address. So now I'm inside of main, or sorry, inside of square 3, and this PS is pointing to the same thing that the other PS was pointing to. I could name these different things all the same, right? This could be PS, or this could be whatever, PS square. Okay. So those are two different ways. And if you look, they're exactly, basically the same thing. It's just here I'm passing in the address of S directly. Here I'm storing the address into a variable and passing that in. Okay. Okay, so if I just declared it as an int PS without the star, that just means it's a regular integer. It's not holding an address, right? It's not a pointer anymore. So this star over here says that I'm declaring a pointer. And so if I didn't have that, the star, then I'm just declaring another integer. And so then what would means is that is an integer that I'm trying to pass into a int star or a pointer, okay? And that's going to cause an error, okay? You know, the way to think about these declarations, it's unfortunate that all it is like a symbol, right? But it really is something completely different. Int star is something completely different from int. Int star is a pointer. It's like a different type. You can imagine it as the name pointer, right? And so PS is completely different. The only thing it can hold is an address. Okay, so there's a question, can the pointer be used with a function that returns int, like square 1? So a pointer can be used, absolutely. I mean, you could use I'm not sure quite what the question is. You could use a pointer up here. You can also return a pointer, which may be what you're asking. And so yes, you can return a pointer, just like you can return a regular type, an integer, or a reference, okay? Trent, I guess so. I forget what you did. Yeah, so Trent, two things. You needed to initialize, you needed to initialize the pointer, right? So you needed to set the pointer to point to the address of some variable, but you also you can't declare inside of the function call. So I can't put int star PS here, right? That wouldn't work. Instead, I have to declare outside and then pass it in, right? So inside of a function call, the only thing you pass in are like literals, like the 3, or variable names. Okay, good. All right, it's cool stuff. Okay, any more questions? All right, so next, so this slide is just explaining everything I just talked about, right? So here I'm saying a pointer can be a formal function parameter, just like I did before, where I made the pointer be a formal function parameter. The formal function parameter has access to the actual argument, which is just what I was saying there, that let's go back here. So this parameter here is accessing the actual argument, which is whatever we passed in, right? Or which is the address of that location. And the address of the actual argument is passed into the formal argument. Okay, does that make sense? And by actual arguments and formal arguments, I'm looking at these. Okay, I'm going to just go back and do a little bit of terminology. This should be parameter to be more specific. I'm going to do some just terminology stuff so we get that down. So so terminology stuff. Inside of the function signature, like in your function definition, these are generally called formal parameters. I'm much better at writing code than English. Okay, formal parameters are up there. And when you do, and this is called, this whole thing here is the definition, the function definition. Okay. And then over here, this is called the function call. And these are called the function arguments. Or actual, I think, actual arguments is the other way we refer to them. Okay. Okay. Next. Oh yeah, so have a look at, so this one, this is interesting. So this is similar to what I did, except rather than squaring a value and then saving the answer in a different variable, here what I'm doing is I'm squaring a variable and saving the answer in itself. All right, so I'm going to do this one for you. So there's our function definition. Okay. And then if I was to do the main and think about what would this function call look like, all right, then what I could do is I could say int x gets 3. So I'm just storing a variable named x that's going to contain the value 3. And then I would call the function by saying square 3, and I pass in the address of x. Okay, oops, need to close that. Okay, because store the address of x, and then I'm going to see out x. And if I did that, then x will now contain, let me do this, x would now contain the 9, right? So which is the x times x. So let me, so this is the answer to that question. So that's what the function call would look like. Okay, so let's kind of think about how is that working. Let me do memory. Okay, and then we have sort of different areas of memory, right? We talked about stack and heap before with new, but let's not worry about that part. Let's just assume that we have, there's my main, here's the memory that I have for main. Okay, and inside of the main function, I have declared a variable named x, which contains the value 3, right? So there it is. So there's my main, and I'm just at this line here where I've declared a variable named x, which contains the value 3. Then I call the function square 3. When I call the function square 3, let's give myself a little bit more space. I'm going to allocate a new section of memory. So now remember, we kind of move into this other section of memory called square 3. And the square 3 has a parameter, a formal parameter called pnum, right? And pnum is a pointer to an integer, so it contains an address. And when I call that function square 3, I'm actually passing in the address of x into that formal parameter, into pnum. So pnum now points to, or if you want to think about it, contains the address of x. So if x is at the address 1000 and pnum contains 1000, right? Because pnum we know is a pointer to an integer. That star makes it a pointer to an integer. So here we are in memory. At this point, we've called square 3. So now we've jumped up here and I've got this pnum, which is a pointer to an integer, which is pointing to the value over there in main. Then I got to parse this statement here. And so to break this one down, this one's just funny because of all the stars, okay? But it's really not that bad. But what this, okay, let's just break down. Let's break down this one. So that this times equals is equivalent to saying, let's see, star pnum gets star pnum multiplied by star pnum, right? These are equivalent. We just break down this star equals, right? So star equals here, or star gets really, it's going to take the star pnum and multiply it by itself. That's what it's saying. So what we're doing here, when I say star pnum, I'm dereferencing the pointer. I mean, whatever pnum is pointing to. So if we break down the statement, we're going to take whatever pnum is pointing to, which is 3, multiply it by whatever pnum is pointing to, which is also 3. So the result of this is going to be 9. And then I'm going to store that into whatever p-num is pointing to, which is down here. And that will take the 3 and replace it with the 9. And then the function returns and we can output our 9. Okay, it's pretty wild. Okay, any questions? All right, last topic. I'm pretty sure it's the last topic. I'm going to come back. These are all together. I'm going to break them down. So there's 3 different things. And we'll come look at that problem. All right. So again, we're still in this idea of taking a pointer or an address and passing it into a function. But the difference now is I'm looking at this const. Remember, this const is very important, right? This const can be used in so many different places. I can use it inside of the formal parameters here, and I can use it over here, right? What's even worse with pointers is I can make the pointer constant, or I can make whatever it's pointing to constant. Okay, so let's have a look over here. So right now, this thing here, p numbers, is a pointer to a constant integer, right? So let me write it down because it's not very clear. So p numbers is a pointer to a constant integer. Okay. Okay. And so what this means, it means that the compiler, when you're running the program, it won't allow you to change whatever the pointer is pointing to. So in other words, if I try to say star p numbers gets 92, right? So I'm going to change whatever p numbers is pointing to and say it now contains 92. That's going to give me an error. Okay. Because whatever p numbers is pointing to is constant. That's a pointer to a constant. Okay. I could, what I am allowed to do is, let's say I'm inside, again, inside of the pointer, the function, I can say int x is whatever. You could say 92, doesn't matter, but I could make p numbers point to that 92. Like I can change what p numbers is pointing to, but what I can't do is so I change the address that's stored inside of p numbers, sorry, but I can't change what p numbers is pointing to, like the constant, the data that it's pointing to. When I like to change what it already points to. Let me do a different picture for it. P numbers, we know, is pointing to some piece of data, okay? And let's say this data contains 7, okay? Then this is fixed. We can't change that. That's 7 there, whatever it is, that is constant, that is fixed. So that is my constant thing. I cannot change that. But what I can do is I can get rid of that, change the address and say, instead of p numbers pointing there, I can make p numbers point over here. So I can change what's inside of here, but I can't change what was inside of there. Okay, that's what that means. Which brings us to the next one. So these are pointers to constant. The next one is a constant pointer. And I'm just going to flip back and forth a couple times. Notice here, the constant was right at the beginning of the statement. So p numbers is a pointer to a constant integer. Here, the const is inside. So here what I'm saying is p numbers is a constant pointer to an integer. Okay, so p numbers is a constant pointer to an integer. So what does that mean? That means that inside of here, I could say, I would be allowed to say star p numbers gets 92, and that's going to be fine. But what I can't do is, I don't know, is say something like, so that's fine, that one's fine. But if I try to say that p numbers now contains the address of x, then that's going to give me my error, we're not allowed to change what's inside of P numbers. You see what I'm saying? But I can change whatever P numbers is pointing to. So if P numbers is pointing to something, I can change that value to be 92. Okay. So that is a constant pointer. And the only difference, notice, is where that const appeared. Here, the constant is between the star and the variable name before the constant was over there. Okay. Okay. So then the tricky, the one that's least tricky, because there's no ambiguity, is you can actually have a constant pointer to a constant something. So in this case, I have a constant pointer to a constant integer. So what that means is P numbers is pointing to something that can't be changed, and P numbers is not allowed to point to anything else. Everything is fixed. Okay, what P numbers is pointing to is fixed, and it's P numbers itself is fixed. So if I try to say star P numbers and give it a different value, that's going to give me an error. And if I also try to say P numbers contains the address of X, that's also going to be an error, right? So in this case, we're not allowed to do anything. It's a constant everything, right? It's a constant pointer and it's pointing to constant data. Okay. Questions on that?
If you can't do really much with it, why would you do that then? Like, why would you make?
So it's used for if you want to create just fixed, like any kind of constant, right? So anytime of constant, we want it to have a certain value that never changes, but we now want it to use it as a pointer. Then that's like, say for example, we ask the user to give us the maximum number of something, and we store that as a constant in a constant pointer. See what I'm saying? We allocate that space and make it a constant. All right. Okay, I'm trying to think where to go because we have 10 minutes. What can I do really well in 10 minutes? Because I feel like what I could do is do this, but I don't think that's going to be helpful for your assignment. So I want to do something on the assignment. Okay. I'm going to make something up. Yeah, don't worry about null pointer. Okay. We're going to use pointers, but I'm going to do pointers with rationals. Okay. Okay. So just thinking ahead, what I might want to do. Let's say that we have the rational class, just like we normally do, right? A regular rational class, okay? And we have inside of the rational class, we have an input file, which I do believe we have used before, right? And the input file can have a bunch of rationals in it, such as 3/4, 7/9, you know, whatever, right? Some rationals in it. I don't remember if they're one per line, whatever they are, okay? And inside of the rational class, we're just going to use a read. We have a read function, and maybe we have a print function. Okay. Okay. So what I want to do is I want to use pointers to read in. So I want to take, I'll put another one. I want to take whatever is stored inside of that input file, and I want to store it. I want to, read it into my program, but store it in an array that is a pointers. Let's call it an array of point. What did we agree on? Did we see APC? I like looking. Ashley's smiling at me. Okay. There we go. So APC rationals, which is an array of pointers to rational, okay, which initially is going to be blank, but then every time I read in from the file, I want to create a new space, right? Let me create a couple here. This is sort of inside of memory, what memory looks like. Okay. So each one of these is going to be a pointer, and then I want to allocate space so that my M numerator and my M denominator are going to contain these values. So maybe 3/4 and so on and so forth. Okay. All right. And then we have our main. And we're going to try and do this. Okay. Let's see. Let's just do that. So here's my int main. Oops. So maybe everybody have a go, since I think it's helpful to kind of even have you think through it. How am I going to, forget about the file right now, but how am I just going to create this array that's going to hold, each item in these arrays is going to be a pointer to a rational object. So go ahead and write a statement to create this array. So I'm going to say it again. I want you to write the statement to create the array. Okay, yep, and we need to have a maximum size. Good, so you can pick a maximum size. So let's say maximum size is 100, sure. I'll go with Jordan. So Casper, you're creating one rational object, but I want an array of pointers to rational. Okay, nice job, Jordan. Nice job, Caden. Trent, you need to fix yours. Caden, yep, you're good. Taylor's good. Ashley, not quite. The size is 100. That's fine. That's good. Most of it, where's the rational? You got no rational in there. Okay, so we got an array. These are going to be pointers to rational. There you go, Corey. That's good. Portia, you're good. Casper, you're good. There you go, Trent. Got it. Okay. Okay, I see what you're doing there, Casper, but hold on tight, because I'm going to talk about it. Remember the dynamic memory we did last time with new? That's what we're going to do is use that instead. Okay, so the first step is just to create the array, and then we're going to worry about this part. But step number one, we're just going to create this empty array. Good job, Allie. Nice job, Joe. There you go. That's good, Ashley. Okay, good. So I think most people got this. So we know that what we're storing are rational pointers, right? And it's going to be called APC, whatever I name that, rationals. And the size is 100. Okay. All right. Now, next step. Before, I'm not going to worry about this. Right now, this doesn't create anything here, right? Instead, what we have are these pointers that are just pointing to nothing or something that's undefined. Okay. So the next step is I'm going to read from the file, and I'm going to do this as not as code, but as comments, right? So then I'm going to, do my open file, right? And then I'm going to read from the file, but and I'm going to read. I'm going to sort of look. I'm actually going to create. What I'm going to then do is I'm going to go ahead and I'm going to have my index. So my index is going to start at 0, and then I'm going to kind of go through it. So then what I'm going to do is do a loop, okay, which is basically says while not end of file. I don't know. This is pseudocode, right? But while we haven't reached the end of the file, then what we want to do is go into our rational array sub something, and then we're going to create a new rational at that location. So we can say something like APC rationals sub-index. Okay. Right. So that just gets us into this point over here. An index, we're going to say starts at 0, right? And then we can increment it. And then we're going to say that is going to be get, and remember my new, I can say now, I can call my new rational. And I can create a new rational empty object. Okay. And so that doesn't store any of these values or anything. All it does is create an empty rational. Then what I can do is I can use that new rational that I created by saying, okay, I'm going to take my APC rationals sub-index, right? And then I can dereference that. So actually, let's do it the other way rather than, so this is an array, we know already about the arrows, so I'm going to just use those. So APC rational sub-index is a pointer, and I'm going to call in read, and I can pass in whatever my file is. I'll just call it my file. Okay, so what am I doing here? APC rational sub-index is a pointer to a rational, right? And the arrow, if you remember, what it does is it dereferences it. So it follows the arrow into my object, and then I call the function. So the function here is read. And what this function does, I'm assuming in rational, is it reads in these values, remember, and it puts the 3 in mnum and the whatever 4 in the denominator. And then once I've done that, I can then increment my index, and it will loop back to the top of my loop. And if I haven't reached the end of the file, I'm going to create a new rational and then, set those values, right? And so what we're doing here is, even though I've allocated an array of 100 pointers, I haven't wasted space by allocating 100 rationals. Instead, I do that on the fly as I need them. Okay. All right, this is very similar to your assignment, except that you're not doing professionals, you're doing courses. Okay, but it's the same idea. You've got an array of pointers to courses instead of an array of pointers to rationals. Okay, got 1 or 2 minutes for questions.
To delete it, would you not put it in this, right? Because wouldn't you have to run through the entire loop? So would you do another for delete?
Yeah. So last time, at the end, once you're done with everything, where you're just going to end your program, then what you'll need to do is loop through and delete everything. And you're going to loop through for index, right? So maybe you only have like up to here. And so you just loop through those and then call delete. Actually, you can just delete the whole array. Yeah, you can just delete the whole array with one delete statement. Yeah. Yep. Okay. All right. So Casper, I already uploaded the last one too. So it's up there. So I'll just do it again. And honestly, the other thing is going through the video. I put the recordings up so you can go through it again.